14. Let's move on to your question 16. 16, it is actually a easy question, right? It's a barometer. If you know that this is a barometer, meaning that this portion here is actually vacuum, meaning that it has no pressure, it's vacuum. Why is it that you are finding difficult? Okay, I'm not really sure, but never mind. I'm going to help you understand this. I'm going to crop this part out, bring it here, delete the entire thing, paste the diagram here. Okay, why is it that you are finding it difficult? Okay, number one, you do not know what is H. So you need to relate H with some number first, and the easiest way is down here. They already tell you that the atmospheric pressure is 100 kPa, and hence this H here is actually the same as 100 kPa. Now that is how the barometer works. If you are not sure, go and read in your textbook how the barometer works. Okay, basically the atmospheric pressure is pressing onto this water surface, this mercury surface, and hence we say that at this particular spot it will be the same as this P atmosphere. This will be at the P atmosphere. So on the other hand, this P atmosphere is also pressed by this column of mercury. Okay, and this column of mercury is represented by the height H. And go and read your textbook. This H will be equal to, the pressure caused by the column H will be equal to 100 kPa. Okay, so if you look here, if you want to find the pressure at this spot, the pressure at this spot will be equal to the pressure exerted by this bit of column of mercury, which is 1/4 H. So what is H? H is 100 kPa, and if you have 1/4 100 kPa, basically you would have 25 kPa, and hence A is your answer. Okay, I hope I didn't go too fast, but like I said, this is really basic content. If you have difficulty understanding, go and read your textbook. And if you still have difficulty, don't worry, come and see me, and then I will explain further. Okay, then for your question 19, it is a slope and all that. You are asked to find work done. Oh, this one is also a basic question, right? So for this question, you are asked to find the work done. So to find the work done, it is quite straightforward, because you know that your work done, oh, why is it so thick? Your work done, okay, is given by force multiplied by the distance. Okay, and you want to find the work done against friction, meaning that this force here must be friction. So work done against friction, your force must be friction. So this guy here must be the friction. And so the friction is somewhere here. Oh, okay, now I see why you guys have difficulties. It's not that straightforward. Okay, this force 25 Newton, you cannot assume that this 25 Newton is equals to the friction. You cannot assume that. It's two different forces. They didn't tell you that this box is moving at constant velocity. So without that bit of information, you cannot say that, oh, this 25 and this F are equal. You cannot. So the work done against friction will be given by your F multiplied by 15. So since I do not know what is my F, I cannot use this formula to solve my friction. But I am told, and do I know what is the weight of this? I do not know. But I know the force exerted is 25, meaning that if I want to find out what is the work done supplied to the system, I can find it out. So work done supplied to the system will be 25 multiplied by 15, which is equals to 375 joules. And because I'm not told the mass, oh, we are told the mass, no wonder. Okay, good. If we are told the mass, then there's a way of solving it. If not, we will be stuck. Now, why is it that I say that I need the mass? Because the energy that you supply to the system, this one here, the work done supplied to the system, 375, must be equals to the mgh plus the work done against friction, because eventually you want to reach this spot. And in order to reach this spot, you must supply the potential difference from ground level to 3 meter height. So with that, you can then put in your mgh right here plus your work done against friction, 375. So from here you can work out what is the work done against friction. So it will be 375 minus 300, so it's 75. Okay, so that's how you get your answer. So remember, if you get stuck in one equation here, do not, for convenience sake, just assume your 25 to be the friction. Okay, it is wrong concept. You need to approach this kind of energy question from how the energy is being converted. So for this case, for this problem, you are supplying energy through the application of this force 25 Newton. So this is your energy in by this force. And so you can convert this 25 Newton into work done supplied to the system. So this 375 is the amount of energy put into this system here. And how you are going to spend this 375 joules is that you want to raise the box from P equals to 0, which is down here, to P equals to mgh, which is here. So 375, you spend it on raising the height of the box. The remaining energy must then go into the work done against friction. Okay, and just by simply subtracting 375 to by 300, you will get this work done against friction. And of course, if the question requires, I can ask you to calculate what is the frictional force along the slope. Okay, let's move on. That is question 19. I thought it is simple, but it is not. So good question, thank you. Okay, then after that is your question 20. Car of this deliver power. What is the constant force? Constant speed and all that. Okay, I know why you guys are puzzled. Okay, for pure physics, you need to be ready to play around with formula. Do not expect questions that just require you, okay, this is the formula that you used to have. These are the parameter embedded in the question. Try to substitute in. Those are NA or combined science question. For pure science students, you need to be ready to play with formulas. Now, what do I mean by this? Look at this question, for instance. You are given power. Okay, you are given mass, you are given speed. So you are given these three formula. So how do you approach this is that, write it down. Okay, you have power, you have the mass, and you have a constant speed. So what is power? Power is energy over time, correct? And how can you get speed? Well, the first thing that comes into your mind may be half mv squared. Okay, but the problem is if you use half mv squared on top, you have this t here, which you have no parameter for it. So you know that you are stuck right now. You cannot use half mv squared. The other one that can help you, P equals to E over T, is that, well, what combines with T to give you this speed? And the answer is distance. And where do you get this distance parameter from energy? Well, work done, right? So this energy is actually work done by the car engine. So if you take work done, then it will become the engine force multiplied by the D equals to T. So once the D and the T gets out, you can see that this part here, D over T, what will it give you? Yes, it gives you speed. So now the equation becomes F times V. And basically you have all the information you need, right? And you want the force, correct or not? Yeah, actually the question gives you some hints. Look at this part here. They ask you to find a constant force, correct? The only way you can get force out of power is by considering work done, because the work done is the only formula that relates energy to force. So with that, just substitute your numbers into it. Your P is 30k, and you have a F, and then you have this 72 km per hour. Remember, 72 km, you need to change it to meter per second. So change it to meter per second. Okay, and you can work out what is your F.